On page 2 of the notes, we get to the order of operations. A very important concept. It's essentially the backbone of all simplification procedures. It's important to know how to follow the order of operations precisely. Otherwise, you'll do something in the wrong order, and you'll probably not end up with the right answer. In fact, the purpose of having an order of operations is so that we all stay on the same page. We'll attack a complicated expression. Our goal is to simplify it, and by all of us following the same list of priorities, essentially a priority list here, we'll all end up with the same answer, and that's to make uniformity so that when we solve the problem, we all get to the same place. Now, there are 4 priorities. The most important one, the place you start first, would be the grouping symbols, and that would include things like parentheses, brackets, braces, and absolute values. As we'll see, that even absolute values can act as a grouping symbol. What does it mean to start with the grouping symbols? It simply means you work inside of those and figure out what's inside there first, and then proceed to go further with the problem. Sometimes you can have nested grouping symbols like parentheses within brackets. Again, you'll work from the inside out on that. And so you start with inside the parentheses, then move on to where you're in the brackets, and then keep moving on from there. So inside to the outside with the grouping symbols. The next priority is exponents and radicals. Then you move on to multiplication, division, and finally addition, subtraction. So addition, subtraction is the last thing you're going to worry about. Off to the right here, you see this little L to R. That stands for left to right. What does that mean? Well, I'll give an example of that. Suppose we had a problem like this. 30 divided by 5 times 2. 30 divided by 5 times 2. Not a real difficult problem, but it's important to understand how to work it correctly according to the order of operations. The issue here, of course, is that I'm dealing with division and multiplication, which are at the same priority level there. Same priority level. So now, how do I distinguish which one goes first? That's where left to right kicks in. You just read the expression from left to right. Whichever operator you come to first, which is the division, you do that first. So 30 divided by 5 first to give you 6. Then do the multiplication. 6 times 2 is 12. And that would be how you do that. So make sure you follow the left to right protocol whenever dealing with multiplication, division, addition, and subtraction. One other thing I want to show you real quickly before we get to some more challenging examples is how to deal with parentheses, exponents, and negative numbers. Take a quick look at this. I have this on page 2 as well. And this is something you want to be careful of as you go throughout the course. Take a look at these 2 expressions here. They're similar in some ways, obviously, but also different. You got a -3 being squared, but in the second case you got parentheses, in the first case you don't. And these parentheses make a big deal. In this problem, at least, they make a big deal. Let's do the easier of these 2 cases. The easier of the 2 cases is the second one. Nobody tends to get this wrong because it's very intuitive. It would say, okay, I'm going to take -3 and square it. What does that mean? It just means you multiply it by itself. Not hard to do. All right, so you get -3 times -3, and that's simply a 9. No worries, not hard. Like I said, no one tends to get that wrong. What about this other case over here? Well, this is the one that people sometimes foul up. Why? Well, it's how they're interpreting things, or perhaps I should say misinterpreting things. When you see a negative sign in front of an expression, all that means is -1 times that expression. The second you write it down this way, then the order of operations is going to kick in and force you to do the right thing. What exactly is it going to force you to do? It's going to force you to do the exponents before you deal with the multiplication, because exponents have a higher priority. So as you go through this problem, you say, okay, I got to do the exponent first. That's the 3 squared, which is 9. Then I'll deal with the multiplication afterwards, because multiplication comes after exponents and radicals. And so at the very end here, then, we'll have a -1 times 9, which gives us a -9. Clearly not the same answer we got over here, which is why it's important to be careful about this, because these 2 expressions, while they're similar, don't end up with the same answer. So watch your step when you have negative numbers being raised to exponents, whether or not you have parentheses. In general, if you don't have parentheses, like this case here, you're going to end up with a negative value, because it's going to be -1 times something. If you do have parentheses, you may end up with a positive value, or sometimes not, if the exponent is, say, odd. So if I had -3 to the 3rd power, that would end up with a -27. So whether you get positive or negative will depend in part on the outside exponent being even or odd. All right, let's go ahead and take a look at some slightly more complicated examples than this. And in fact, the problems we're going to work at now are going to be very similar to the first several problems you'll deal with in assignment 1. I made sure to give you a lot of challenging problems at the beginning of assignment 1, sort of as a little boot camp to run you through the order of operations. It's very important you know how to do the order of operations. So As you go through the first few problems in Assignment 1, if you find them challenging, well, okay, that's to be expected somewhat because I am challenging there a little bit. Make sure you know how to do this order of operations. The whole course isn't going to be that way, but I want to make sure you get this down at the beginning because if not, it's going to be dogging you for the rest of the class, and you don't want that happening to you. All right, so moving on to the next page, page 3. Let's write down our first example here. And let's see what we got. It says to simplify this expression here. And we got some nested grouping symbols. There's some brackets involved and parentheses inside there, as well as some other things. Okay. Now I'm going to take this problem a little slower than perhaps I normally would just because it's our first example. And if you like to work things a little faster and you feel comfortable with that, by all means. In time, every one of us tends to sort of adopt our own pacing, and that's perfectly fine. You don't want to push yourself too fast where you make a mistake. On the other hand, you don't want to purposely drag your feet. If you can be a little more efficient about things, that much the better. That way you're not taking really longer than necessary to grind through a problem. All right, so we take a look at this expression here. We want to simplify this. In the end, it's just going to be a number. Where do we begin? Well, we notice we got nested grouping symbols here, so that's our top priority. We go right inside to where the parentheses are, 2 minus 5. The innermost part of that, 2 minus 5. And what is 2 minus 5? Well, of course, it's a negative 3. So you got negative 3 right there. And that's all I'm going to do for right now. So I just say, all right, that's all I'm going to do. I could do more than that, I suppose, but let's just go ahead and put that negative 3 there. If you want to keep the parentheses, you could. I don't know if it's really helpful at that point. A lot of times a textbook will keep the parentheses there, but maybe you'd rather not have them because of how you look at things. So I might just write it like this. That might help you see what you're going to do. A lot of you probably remember how to handle this situation where you got 4 subtracting off a negative 3. How do you deal with that? What's the easy way to deal with that? Remember how you make these 2 subtraction signs, or say 2 negative signs into 2 plus signs, and that's going to give you a 7. By the way, you may wonder what's the justification for that. It's the way subtraction is defined. So in other words, when you talk about subtraction, say a minus b, what does that mean? That simply means a plus the opposite of b, a plus negative b. So if I add the opposite of negative 3, it means I'm going to be adding a positive 3. And that's just the definition of subtraction. Most of you probably know that already, but I thought I'd just throw it in there because as we go along with some of these examples through the first assignment, we'll be hitting a lot of basic details that you get typically in a, say, a pre-algebra class, and maybe you're a little hazy about that. I'll try to jog your memory. All right, so what do we have here? We just got basically a 7 in there, right? So like we did before, that's 4 plus 3 is a 7 in there. Now that 7 is still being multiplied by the 3 there. So I have to indicate multiplication somehow. I could use a dot like I mentioned on the first page of the notes, or I could just keep the brackets there if I want. I could turn the brackets into parentheses if you want. There's lots of options, but you just want to make sure to indicate multiplication still. All right, what's next? Well, technically speaking, I should worry about this exponent next and get a 6 squared into a 36. Could I also attack the 3 times 7 at the same time? You could, sure could, because this addition basically says both of these are going to be done long before you have to deal with addition anyways. But let me take it nice and slow, like I said from the outset here, and I won't worry about this 3 times 7 yet, though you could do it if you want. So 6 squared is 36 there. Now what? Well, now you have to do both the multiplication and the division before you deal with the addition. So let's go ahead and do those at the same time. And 36 divided by 9 is 4. Finally, addition is the last thing we worry about. 21 plus 4 is 25. And there we go. Maybe that's a little more long-winded than you would have worked it out, but hopefully I didn't lose anybody along the way either. All right, let's try another example here. This next one, I'll try to be a little more efficient about. Show you how to be a little more efficient about some of these problems. And let's see what we got here. Number 2, 6 minus 8 cubed. And then we got plus the square root 25 minus 9 here. And then we're going to subtract off 3 times the absolute value, 7 minus 12. All right. So the thing you want to notice about this problem is how it naturally breaks up into 3 chunks. Take a look at your 3 chunks here. You got this chunk here, and this chunk here. How are these naturally broken up that way? Well, it's because the addition, subtraction, those are going to be the last things you deal with. So all this stuff here has to be worked out before you try to add it to this middle piece. That has to all be worked out, and this last piece has to all be worked out before you get around to adding and subtracting. So your addition, subtraction signs will often naturally break the problem up into sort of smaller, manageable chunks for you. And it's a nice way to work the problems. It kind of gives you a good pacing, allows you to get stuff done efficiently without maybe going too fast and making a mistake along the way. All right, so let's go ahead and work this problem through, each chunk at a time here. So 6 minus 8 is negative 2, of course, cubed, plus inside the square root, 25 minus 9 is 16. And now here at the end here, you see how this absolute value acts as a grouping symbol. So we're going to work the stuff inside. 7 minus 12 is a negative 5. So I work that first, then I'll take the absolute value afterwards. Now, as we move along, negative 2 cubed is a negative 8, because that's negative 2 times negative 2 times negative 2. So you got 3 negative signs, an odd number of negative signs, it's going to be negative. This is an example of taking a negative number raised to an odd power and getting a negative value out. I alluded to that in the previous, earlier in the video. Square root of 16 here is, of course, a 4. And then towards the end here, we're going to be subtracting off something. Subtracting off what? Well, let's go off to the side of this thing, right here. What is the absolute value of negative 5? Well, that's easy. It's just a 5. And now, what is this 3 doing to that 5? Well, the 3 is multiplying, because when you have this number right out front of the absolute values, it's multiplication that's going on there. You can put a little dot just to remind you of that. So that's 3 times 5, which of course is going to be a 15. And that 15 is being subtracted off. All right, now what happens? Well, now you just work it from left to right, because all these operators, addition, subtraction, are the same level, same priority. So you just work it left to right. Negative 8 plus 4 is negative 4. And then, depending on how you want to look at this, you might say that's negative 4. I'm going to add the opposite. So I'll add a negative 15. That makes it maybe a little easier for you to see. You get a negative 19. Not that you have to do that extra step, but for some of you it might make it a little bit easier to see why it's the case. So there's example 2, and all I really want to emphasize is this idea of breaking up into chunks by the addition subtraction steps, because you know that's going to carry all the way down to the very end, and so it's a natural way to work the problem. All right, let's make one more example here, make it a little more interesting, because these problems will definitely get a little more challenging than this. In fact, let me give myself a little more room here. And when you go to the homework, you're going to come across a lot of these, like this next one. And that's intentional, because like I said, I want to push you a little bit, kind of like a little mini boot camp with the order of operations, to make sure you get it down cold before you try to move on further into the course. All right, so here we go. We got a negative 2 squared minus 7 times 8. There's some parentheses there. And minus 4 times 3 there. All right, all over. And then we got 3 squared minus 12 divided by 6. And then that's going to be a minus a negative 5 squared. Okay, so there's the problem. Definitely a little more complicated maybe than the last couple. And what's the overall structure? This is what you want to notice about this problem. The overall structure is a fraction, isn't it? You got a numerator, you got a denominator. And essentially, each one of those needs to be simplified independently of the other. Then you'll have a fraction at that point that might be reducible to lower terms. So we'll worry about that when we get there. Let's just go ahead and take it one step at a time. I'll go ahead and do the numerator first, write it down, and then we'll tackle the denominator. In the notes, I sort of do both at the same time to save space, but it's probably going to be easier for you to follow me in the video if I do them one at a time. So let's go ahead and do the numerator first here. So here's the numerator. There we go. We got a negative 2 squared minus 7 times 8 times 3 in parentheses. Okay, so notice your grouping symbols, the parentheses. Let's go ahead and start inside there. Not too difficult to do. We got 7 times 8, which is 56. 4 times 3 is 12. 56 minus 12 is what? 44. At this point, you really don't need the grouping symbols anymore. So if you want to get rid of them, you can. You don't have to, but let's just get rid of them. You don't need them. Now, watch your step here. This next step is one place a student might make a mistake without realizing it. That's how you're going to handle this negative 2 squared. Remember we talked about at the outset of this video that the way to interpret that is a negative 1 times 2 squared. And when there's no parentheses, you're going to get a negative answer, but that's exactly what you get. Negative 1 times the 2 squared is negative 1 times 4, or negative 4. So watch your step there. It's not a positive 4, it's negative 4. If there are parentheses around that negative 2 and the square is on the outside, you'd have a positive 4. But without the parentheses, it's negative. And finally, negative 4 minus 44, negative 48. Not too bad. There's your numerator. Now let's do the denominator. Let's put it, say, right here. Well, we have a little bit of space there. All right, how's the denominator going to work? Well, it may not be quite as tricky as the numerator. There we go. Alright, so how do we tack this? Well, take a look. You've got, it's like grouping symbols here, but really there's nothing to do inside there. The negative 5 is just sitting there. So what's the next level, or the next priority? Squares, right? You want to deal with those squares. So this 3 squared is a 9. And toward the end there, you've got this negative 5 in parentheses squared, so that's going to become a positive 25. So that's in contrast to the negative 2 up here that did not have parentheses with a negative 4. This negative 5 in parentheses is, you're squaring that negative 5. Negative 5 times negative 5 is a positive 25. Still being subtracted off, though. Now what happens? Well, as you stare at this, you realize the next priority level is going to be this division. It has to be taken care of before you deal with the subtraction. So 12 divided by 6 is 2. And then, of course, you just work it from left to right. So 9 minus 2 is 7. And then 7 minus 25 is a negative 18. So there's your denominator. Not too bad. But just be careful. Don't rush these order of operation problems, because if you go too fast, you're going to make the chance of making a mistake a lot higher. All right, so let's go ahead and write down what we have here. What we have is a negative 48 on top. I'll try to color code this for you. I like using colors in these videos. I think it makes things stand out, maybe hopefully easier to follow. Sometimes I get a little obsessed with them, so try to avoid doing that too much. At any rate, there's what we have, numerator over denominator. Now we got to simplify this. Feel free to take your time when you simplify. Again, I'm encouraging you not to work these problems too quickly. So one of the things I like to do is, first of all, take care of the obvious stuff, like those 2 negatives. If you got 2 negatives, like multiplying 2 negatives, dividing 2 negatives, means you have a positive result, don't you? So we know we have a positive answer in the end. What's the other thing we have to deal with? We have to reduce that to lowest terms. Now, in a lot of these problems, you can just see how to do it in one step. That is, you find the largest number that goes into 48 and 18 evenly, which is going to be 6 in this case, isn't it? But suppose you didn't see the 6. Suppose you say, I don't know what it is. Fine, that's all right. Just find something that they have in common. Like what? 2, right? Because they're both even? All right, so if they're both even, we know 2 has to work, so divide them both by 2. And then stare at it a little bit longer and say, well, what else could we have in common here? How about 3, right? So there we go. They're both divisible by 3. All right, now we're at the end of the road, essentially. So our answer is 8/3. Or is it? Well, this is one way to write the answer. That's a fine answer, but there are other options. This is an improper fraction. We could do the mixed format by having the 3 go into 8 twice, so you'd have a 2 2/3. And you could even have a decimal approximation, which would be about 2.6666. Let's round off to a couple decimal places. There you go. They like to do decimal approximations for word problems. That's quite frequently the case. At any rate, you want to be flexible, especially if you're in a multiple choice environment. You may not see this as the answer. Don't panic, though. Look for other options, right? Look for this to be there, or perhaps it's a decimal approximation. Look for all 3 of these. If you don't find any 3 of those there, okay, now you can start to panic because something's wrong. But as long as one of these 3 is there, you got it. And that's how you do that type of problem. So overall, it's a fraction. Do the numerator and denominator separately, and then just take this thing to lowest terms and look for your options at the end. And that's how the order of operations works. And I'll just tell you good luck on the homework. Of course, if you ever have any questions on the homework, feel free to let me know what's bugging you, and I'll be glad to help sort it out with you.